Okay, so I'm on my last bar here, so we'll see if I can get this done. So this is line 18, a3d Diamagnetism, magnetic flux electrons, orbital velocity, trajectory, exponentiation, Wow Seti, part 108, and that was the Google thing that we did for it. So for my thoughts, February the 4th, 2012, I added lines 18A, 3E, F, G, H, I, J, K, L from the keywords found in 18A, 3D. So basically this particular module was divided into more. And other topics on it are radial parabolic trajectory, exponentiation, and binomial theorem. So this is something levitating over these pyrolytic carbon. That's what diamagnetism is. It's the property of an object or material which causes it to create a magnetic field in opposition to an externally applied magnetic field. Okay? So my thought, the diamagnetism is basically what you want to create in the inner core of a UFO, where the middle part floats above the rotating part. Not sure if we can get that to work, but it's an idea. So this is magnetic flux. Each point on a surface is associated with a direction called the surface normal. The magnetic flux through a point is then the component of the magnetic field along this direction. And here's the nucleus with the electrons. And this is orbital velocity of electrons around their nuclei. The orbital speed of a body, generally a planet, a natural satellite, an artificial satellite, or a multiple star, is the speed at which it orbits around the barycenter of a system, usually around a more massive body. And here's another graph. Torque on a dipole. This came up, so I looked it up to see what it is. And radial parabolic trajectory. That's what that looks like there. So a radial parabolic trajectory is a non-periodic trajectory on a straight line where the relative velocity of the two objects is always the escape velocity. And there's the different components for it. February 4th, 2012, my thoughts, to the power of y, comes up in the alien message from January 21st, 2012. Google what is the power of y, and this came up. Graphs of y to b to the power of x for various bases. So graphs of y to b equals bx for various bases. Each curve passes through the point 0, 1 because any non-zero number raised to the power 0 is 1. At x equals 1, the y value equals the base because any number raised to the power 1 is itself. Then the next thing comes up is exponentiation is a mathematical operation written as bn. It's the base and the exponent. That's what that looks like. Exponentiation is used pervasively in many other fields, including economics, biology, chemistry, physics, and computer science, with applications such as compound interest, population growth, chemical reaction, kinetics, wave behavior, and public key cryptography. These are all the words that are mentioned in this section here. Okay. And the keywords are going to be further explained in those videos there. My thoughts, February 4th. This came up during my research. I'm not sure what it means, but it's talking about ancient math and definitions of it on Wiki. So I'm wondering if it's important or not. I thought I'd mention it here just in case. Binomial theorem. In elementary algebra, the binomial theorem describes the algebraic expansion of powers of a binomial. That's what it looks like. Here's a diagram. The first 6 rows of Pascal's triangle. Says the coefficients appear in the binomial expansion are known as binomial coefficients. They are the same as the entries of Pascal's triangle. So I'm still not sure what that means, but that came up in this video here. And it's talking about expanding the power of x plus y and into a sum involving terms of the former ax, b, y, c, where the coefficient of each term is a positive integer and the sum of the exponents of x and y in search of the term n. Okay, so that's it for that video. We'll go on to the next one now.